Interpreting data. In the previous video, we discussed several different ways data could be visualized. The first way was the bar chart, which we mentioned was great for comparing quantities. The other way was the line chart, which was great for showing trends over time. Is data going up or is it going down as time goes on? The other way was the pie chart, which is great for comparing ratios. By looking at a pie chart, you can quickly see who's the majority, who's the minority, and everything in between. And the last type we discussed was histograms, which is great for showing frequency. It's great for showing how frequently data falls within a certain range of values. In addition to discussing these different types of visualizations, we also discussed how what makes visualizations great is its ability to quickly communicate a message, much more quickly than a table filled with just text would be able to communicate that same message. They're so effective that oftentimes we don't even have to look at the data specifically to see what that message is. We can look at a pie chart and quickly see what is the majority without looking at the specific data. We can look at a bar chart and instantly know which value is the biggest, which value is the smallest, and how much smaller or bigger without looking at the specific data. Visualizations communicate messages very well without having to go into specifics about what the data is. But therein lies the danger with visualizations. Because people have a tendency to look at visualizations without looking at the specific data, that makes it easy for sneaky people to trick people, to mislead people. Which brings us to the main topic for this video, the ways data visualizations can mislead people. Consider this bar graph that shows the mortgage interest rates, how they varied from year to year over a 5-year span. At first glance, it appears that the mortgage rates are going up very significantly each year, especially in 2011 and 2012, where it seems that the rates are doubling those 2 years. However, when you look at the actual values on the side, you see that the values on the side, they don't start at 0. It starts at 4.14 and ends at 4.152, meaning the range of the graph is just barely above 0.1. Henceforth, since we're using such a large graph to illustrate such a small range of values, even the smallest, tiniest of jumps is going to look big on this graph. However, if I were to start my vertical axis at 0, as most graphs do, I get a bar graph that's a much more accurate representation of the data. I get 5 rectangles that are barely different in size, which, when you look at the actual data, makes sense because the values are hardly different in size. They're just made to look that way. Another trick that can be employed on people is data omission. The line chart that's currently in front of you shows how the profits of a certain company varied from year to year. As you can see, it was pretty up and down. It didn't consistently go up or consistently go down. And that's not a good thing if you're trying to market your company to investors. Ideally, investors want to invest in companies that are showing consistent growth. But clearly, this chart does not do that. However, suppose that instead of showing our profits for every single year, we instead just show the profits for every other year. Right? Now, when you look at it that way, now it looks like our profits are steadily going up over time. By omitting data, we're able to tell a story that isn't representative of the actual truth. Another way data can be used to mislead is by falsely proclaiming that correlation means causation. Here's what I mean by that. In this graph, we see how the number of Cypals graduates changes over time, and also how the amount of Yeezys sold in stores changes over time. And as you can see, as the number of Yeezys increased, the number of Cypals graduates increased. But however, common sense tells us that these are just coincidences. That the amount of Yeezys sold has no effect on how many students graduate from Cypals. Now, while that might seem obvious to you, if you were to send this graphic to 1,000,000 people and 100 people out of that group were to believe it, while that's a small percentage of the people, that's still 100 people you managed to influence. And that, depending on who you are, depending on what your goal is, 100 people may be all that you need to carry out your unethical plan. And then another way, the last way we're going to discuss how visualizations can be misleading is with pie charts. When you look at the pie chart, without looking at the actual numbers, you would think, wow, the vast majority of people inside fair support clear backpacks. Because that's how it looks. The pie is majority blue with just a small section of red. However, when you look at the actual percentages, 52 versus 48, in actuality, the difference is not that huge at all. It's actually almost equal. Right? And guys, just a quick disclaimer, none of this data is real. I don't know how many people actually support or don't support clear backpacks or what the mortgage rates were in 2011, but nevertheless, my point still stands. This pie chart is another example of how a person can be duped into believing a falsehood because they looked at the visualization without actually looking at the data. So, in summary, in conclusion, always examine the metadata, or in other words, the data about the data, right? And ask questions. Ask questions like, where was the data collected? Was it collected in a majority low income area? Was it collected in a majority black area? Was it collected in a majority Muslim area? These are all factors that can significantly affect how your data comes out to be. Also ask, who collected this data? Is the person who collected this data have a reason to be biased? Does that person have an agenda? Does that person have a reasonable motive to make a false message seem true? Also ask, how long ago was the data collected? Is that data still relevant today? How large is the data set? If I want to conduct a survey to find out the most popular Ultimate Smash character at Sci Falls, but I only ask three people, one said Kirby, another one said Pikachu, and the other one said Bowser, is that data that I can take seriously? Can I draw any meaningful conclusion from that data? Obviously not. So, in summary, when looking at a visualization, always examine the metadata.